All right, let's start off with the basics on what our unknown project is. So if you all refer to your lab supplement, that big old main document that I have you guys work with for together with the lab manual itself, it clarifies that it's kind of the subsequent step, part 2, if you will. It's just going to be bigger, stronger, better. The idea here is to now collect everything you've learned so far from labs 1 all the way down to lab 38 or so, and we'll heavily focus on labs 19 through 38, which are the metabolic assays, as a way to kind of test how far you've gone along. Virtually every professional microbiology course, every college grade microbiology course has this type of exam. Technically, it's a project. Technically, it's an exercise. Technically, it's a lab. But in reality, we're kind of testing you on your skills and your knowledge. It's putting together everything you know so far based on the idea of, can you identify an unknown all on your own? It's still timed like the first one. It's done kind of privately. It's pretty much all done on your self-reliance, right? You can use all the materials that you have available to you. So you can use your notebook, your manual, your videos, everything that you have, with the exception of other people, technically. The only people you should have access to should be myself or your instructors or any of the lab technicians that are providing you with materials. So it's meant to be you surviving based on all the knowledge that you've acquired so far until the end of the semester, so that you can come up with the identification of an unknown based on its properties. Now, what's interesting about this one, as opposed to the first unknown, is here you have to design your own flowchart. As opposed to during the first unknown, we give you one, kind of an easy one so you can navigate through it. Here, you really have to come up with your own flowchart itself. So it's going to be a little bit more complex, right? So again, this is what happens at the end of most micro courses. Some people do it in parts. Some people do it all flow through. Some people do it throughout the entire course. We do it as our final project. So this is it. Think of it as the final exam for the laboratory portion. That's the idea. Now, for this, to ensure that everybody is on par, we give you as much information ahead of time to make sure that, again, there's no questions. Those very often frequently asked questions, ideas, you'll see me address this in a moment, is to make sure that you have a document that has all the information you need. That way, nobody goes, oh, I didn't know, or I didn't have access to that, nobody told me. We really try and prevent that at this end, right? The idea is you can do this on your own. And now that we've prepared all these documents for you, it is pretty much self-sufficient. As long as you're reading, as long as you're following along, you should be okay. So I'd encourage you to go back and look at your first unknown. Again, reminding you that it's just a bigger, better version of it, right? So it has the same rules, the same ideas. For example, you're still required to complete a gram stain as a way to measure your skills in staining and microscopy. You still have to learn how to grow things. And then also, we now add some confirmatory tests. You're going to hear me use that word a lot. The idea here is sometimes to make sure you have the right answer, we let you do some extra tests just so you make sure that you're right on the nail, on the nose for those particular IDs that you make. So for example, we have our confirmatory ROS tests. So those are reactive oxygen species tests, your catalase and oxidase tests, for those you remember from your metabolic assays. Those will allow you to confirm if something's gram negative or gram positive. You may need to read back again, or may need to do a little bit of Googling sometimes to figure out how those ROS tests help you figure that out. Another thing you're going to be reminded is that the first unknown was basically worth half of the amount of this one. This is worth an entire grade. So this is kind of a make or break system. It is a good opportunity for you to kind of show what you know and earn some easy points. It's 10% of your grade, at least at this point in time. So it's well worth trying that out. Make sure you get as many points as possible, right? Now, as opposed to the first unknown, so some of those changes that only worked on the stains and on motility, here you're going to use that and the metabolic assays. So including those last set of labs we've been working on lately, with the exception that we don't use things like antibiotic resistance or anything like that, right? And then rather than giving you 6 to 8 possible organisms in your flowchart, Now you're going to have a much larger group of organisms available for you to identify. So again, bigger, badder, stronger than what it was before, right? And so we'll normally call that list of possible organisms, possible bacteria you're going to be identifying as the bug list. That's kind of what we've lovingly renamed it thanks to our predecessor teaching this course. So that's what we call it. We just call it the list of organisms is just the bug list, right? And then rather than relying on just one set of tests, we usually even give you multiple sources of your organism so that you can maintain on your own, so you can also demonstrate your ability to maintain your own culture. In other words, prove to us that you can do aseptic technique, right? That's the overall bit. So there's a little bit of changes here and there, whether this is done in person or even digitally. That's that. So now the reminders, the breakdown, this is already in the syllabus, but just in case, you can always see this here, right? Is that your entire 10% can be equated to 100 points. That way you can see kind of where it goes. So 10% is worth 1 point. 10 points is worth 1%, the other way around, right? And then you break it down into your staining, your reactive oxygen species tests, the flowchart itself, which is worth major points. Here's about half of your points. And then you have a report at the end, right? That typical report is due on the same day or a day before, something like that, depending on our schedule, before your final exam, right? So you have plenty of time to work on this. And that's usually the final day you can submit your report, usually again by midnight, 11:55 p.m., again, depending on the schedule, right? That's the idea. Now, keep in mind that the flowchart, since it's worth a lot of points, that's where we kind of really emphasize any type of mistake, any type of guideline, any type of checklist. That's really where everything goes. Everything else is based on your skills, so it's more or less based on you. But the flowchart, here's where we focus heavily on what you should be doing. So keep that in mind, all right? We'll go with that. So the interesting thing about this is the fact that since we're going to have to go through all these flowcharts, which is, again, major points, normally I like to give everybody a heads up on how complex this process gets. Regardless of how many instructors we have, how many graders we have, how many support we have, the flowchart, since it's a major project, a major set of work, there's a little bit of a challenge. Even if it takes you, for example, let's say on a good day, 3 to 4 hours to put it together, which is fine, keep in mind that even us as graders of that assignment, it might take us a good 5 to 10 minutes to simply take a look at it and make sure that everything's there. Problem with that then is if you take out the group of students that we have, even per section of 32 students or roughly so, that's about 320 minutes per section. So that's about 5 or 6 hours worth of solid grading, like nonstop. And so if you do that across many sections per day, that's quite a bit of time to just focus on the grading of the flowcharts. So it's imperative not only that we emphasize that we want the best flowchart you can come up with as early as possible, so we get as much time with it, but also as complete and as thorough as possible as well. Keeping in mind that we also remind you that, hey, look, if there's going to be mistakes, which often there do appear, usually they're minor, but those regrades also take time. And so that means since we have a little bit of a backlog of people that we need to make sure we grade their materials, your regrades or your resubmissions or your fixes usually kind of go back to the end of the line. And so that means you may be waiting a longer period of time for even just a silly thing like forgetting to put your name on the actual document. So the regrades themselves don't really change the end grade because you do lose those points, but you can't complete your project without having a complete flowchart, a fully graded flowchart itself. All right. So in order to keep this fair, to make sure that everybody's equitably treated in terms of grading time and they can complete their projects, there is a little bit of a queue. You'll hear me mention this often, this idea of first in, first out idea. So if you submit it early, you'll be yours will be the document that we focus on. So as long as you stick to that process and as long as you're not having to do many regrades, you should be able to have your flowchart graded so you can start off. So just be aware that, again, it is a complex process. It's a very, very organized system that takes quite a bit of time to grade all this stuff. So please be aware that your flowchart is the most valuable piece, and that prior to submission, you really want to double check that it's correct many, many times. Ask for help from others, have everybody supervise you, check you, double check you, triple check you. You'll see me say this many, many times too, to ensure that when I receive it or somebody who's grading it receives it, can spend the amount of time that they need to and then give it back to you and you're ready to go. Rather than going through multiple rounds of, oh, okay, I made a silly mistake here, or I forgot to put my name, I forgot to underline my organisms or something just like that, that'll cause you to just be put on hold over this queue of hundreds of students waiting to get the same thing done. All right, so you're gonna hear me emphasize this a few times. So please value, as you can see from the previous slide over here, that flowchart is worth the major amount of points, okay? So I'm gonna continue to emphasize this many, many times. So what's the plan? So ideally is on the very first day we start, so we will tell you when that is, we'll let you know day one of this particular project. That first day usually encompasses obtaining the actual unknown, whether it is the number or the actual slant contains the organism, the one you don't know about. And then it'll include also your documentation, so your lab manual materials. It'll include you obtaining the sources of information for that particular unknown. And then normally that's when you do your gram stain too. And so the gram stain, just like in the first unknown, it takes about 10 minutes for you to complete. You have to submit a little report for the points. In this case, it's worth 10 points. And then at the end of this, if you got your confirmatory tests, your ROS species tests done, then we will be able to say, hey, good job, here's your points, and request your bug list. So you should be exchanging your information for a list of possible organisms that could be inside your slant, or based on the unknown that we assign you, as well as typically we give you our neat little white piece of paper containing this giant grid that we call the matrix, right? That's where you're going to be collecting your information. At that point in time, you're usually given a day or two, depending on your section, to complete your flowchart based on that information by collecting information from Bergey's manual. I'll emphasize that in a moment too. So once you're done, you submit your flowchart for grading. And then after that, it's kind of easy sailing. The idea is the tests that you're supposed to take will go one by one, limited in order based on your graded flowchart. And then until you're done, until you can come up with a possible or plausible answer to what your unknown is. And then after that, you're good to go. That's more or less what we need to do over here. Now, if we're going to kind of break that down a little bit further, just in case, again, keeping in mind that this is what we would do in person, is you would obtain the unknown or unknown number or both. Usually there's some sort of list that you can sign off saying this is mine or something like that. And then you can collect all the information that you need. You usually observe your organism. You kind of take down any kind of cultural characteristics, this idea of what does it look like? And does it have any color? Is it growing heavily? You know, all the stuff that we learned early on in the labs as macromorphology, right? Then normally we would provide you with the actual organism itself so you can transfer it onto your subculture slants. That way you can preserve two, one as a backup in case something goes wrong, and the other one is what we call like a working culture, the one that you're using. So you then proceed to your gram stain, which again, you're all familiar with how this protocol works. You stain it, you do your washes, usually about 5 minutes. So we give you about 10 minutes to complete this. And then you submit your little report to let us know, hey, I obtained a gram positive. It is a rod, it is a sphere. So you'll tell me whether it's bacillar or spherical, that kind of thing. And then you'll also want to do your reactive oxygen species test to confirm that what you did is correct, right? So here you have it listed as well as how that usually works. So make sure you're familiar with those tests prior to starting this protocol. And then at the end, once you exchange for your bug list, at that point in time, we kind of let you go free and loose so you can do a little bit of research and read whatever material you need to obtain for that bug list you were assigned. Everybody's bug list is different. The idea is we don't want to give everybody the same set of organisms, otherwise everybody would solve the same thing, right? So we want to make it a little bit of a challenge. So everybody's set of organisms, everybody's set of possibilities is a little bit different. So we do have about 100 or so different possibilities we're giving you a list of slightly less than that. So slightly less than half about those. So that should be enough of a challenge for you guys to complete in roughly about a month or so, right? So that's the idea. So on the second day, if we're going to look at this, now we want to look at, again, how we're going to do our tests. On day one, you did your gram stain, you got your flowchart, you built it, you submitted it for grading, and usually we should be able to get it back to you within a couple of days. After that, you're more than welcome to start performing your tests. Now, again, to remind you, on the second day, while we're waiting for your test to start, normally the instructor, the graders, etc., are going through those flowcharts on a first come, first serve basis. Remember, it's part of that queue. And so again, reminding you that the average time of grading one of those, even for an instructor under perfect conditions, right, it will take somewhere between 5 to 10 minutes. That's assuming everything in that flowchart is perfect and it looks great. Going through one by one each of those tests takes a little bit of time. And so the same way you can think about you crafting that flowchart took you enough time to figure out what each test was and to design it, we have to decipher that from your particular flowchart. So that takes some time. So as we decipher it and we go through your flowchart, we'll start finding any small mistakes. Nobody typically is kind of at a grieve lost, points. Is typically something like, hey, you forgot to include your section, or you forgot to number your unknown, or you forgot to order things positive and negative, something small enough that even then we have to return it to you to let you know, hey, this is incorrect, please fix it. And so usually there's about a loss of about 2 to 5 points per each mistake. And yes, those can be repeated. So those accumulate. And so when we send it back to you, that means we move on to the next person, to be fair. But that means that whenever you're done completing yours and you send it back to us or bring it back to us, that means you get put to the back of the list. It's not fair for everybody else to be waiting. So you have to kind of go back to the end of the queue while we complete everybody else's materials. Okay, so everybody needs to be treated fairly. Everybody should have a chance of having their flowchart graded as soon as possible. Right now, after that's done, after you get an approval of your particular flowchart, you'll get some points out of 50, obviously, and it'll say literally on it, approved. If your flowchart does not say the words approved, it's not ready. You cannot start. So ensure that when we confirm with you, when we grade it, when we give you some numbers, that your flowchart says the word approved, okay? And then after that, we'll continue this portion of what we call phase 2 of the tests, which means that's when you actually get to do stuff. That's when you actually go test by test to figure out the identity of your organism. So that's when you get to do all labs 19 through 38. All of those ones are performed. Keep in mind that you don't get to have a plethora of them all accessible at the same time. Rather, you can only do one at a time. The idea here is pretty simple. Rather than just saying, here, waste all of this material, you have a strategy behind it. Saying, okay, well, in order for me to figure out the best way to identify this organism, I need to perform test number 1 and then test number 2 and so on and so forth. That way, again, you minimize the amount of time that is wasted, you minimize the materials that are wasted, and you come up with a reproducible conclusion at the end. Okay, so that's the plan. Now, since sometimes these tests can take a few weeks, we always encourage you to make sure you're replacing your original organism, and reculturing it to keep it nice and fresh. So that will happen if you're working with a live organism. Now, to remind you, there are some documentation that we're going to be playing with. These normally are at the front of our lab, or they're available digitally on Canvas. We'll show you where those are as well a little bit later. But if you check on Canvas, these have already been posted as well. But those include your gram stain report. It might look a little bit different as time passes by. Your reactive oxygen species test, which means your oxidase and catalase test, depending on which one. Again, I remind you, make sure to review which one does what. There will be a matrix. That's the major one. That's that very large document that we provide to you either at the beginning or somewhere throughout the process so you can fill it out. So it's this giant grid. That's our matrix, right? And then depending on when you're performing your tests, you may need a materials requested or a materials request quarter sheet. Those is usually when you say, hey, I would like to perform this particular test. And you usually also have to explain why. So those are the main ones. Those are the big heavy hitters of the documentation that is usually available in hard copy, or what we strongly recommend is use Canvas so you can have digital versions of those. Now, the matrix itself is really where you're going to be collecting the information from the bug list. Typically here, you will place on the left-hand side of the columns where your organisms go. See if we can get this going over here. There you go. So your possibilities should be listed here. I also encourage you to write these down alphabetically by the genus, by the genera, right? That way they can be traced a little bit faster. And then on the top, you usually have to declare which type of tests you have. Now, your particular matrix has those already filled out, so you don't have to do that, right? So you probably, what you want to do here is kind of do some annotations on how long does this take, what type of test, what type of medium, that kind of stuff. You can put it up here too, right? And then for your materials requested, if that is required for you in phase 2, you'd normally say, hey, I need one slant of this, one swab, one loop, one vial of mineral oil, or something like that. Those are where you're going to be listing these guys. Again, one of each. Again, we're not letting you just waste materials. You're going to be a proper technician in this case. And then you also have to give us a reason behind that. In other words, you have to explain, hey, I need to separate this enterobacterium from this particular set of organisms, and I need to separate these 3 guys from these 5 guys, or something like that. So you need to give us a justification on why that test is performed. Now, to fill this guy out, you need some information, right? You have your bug list, you have the tests you can perform, but how do you know how do they test? So just like you were learning in labs 19 through 38, certain organisms are positive, certain organisms are negative, certain organisms have alternate results, and you figure out by testing them. Well, how do you know out of this massive amount of information what is what? Well, for that, we actually provide you with the correct source. Here, it's actually kind of fun because you get to do a little bit of investigative work by reading a very, very massive book. Now, the cool thing about this is that this is the condensed version. This is the Cliff Notes about it, and it's referred to as Bergey's Manual of Bacteriology. At this point in time, the original source of this information, the non-condensed version of this, is about 15 books. Each book is about 5,000 pages, and even those tomes, to be honest, for the word that they actually require, they're kind of expensive and kind of hard to find. You usually find these only at very specific libraries. So instead of having you access to this giant encyclopedia of information, as you all understand, it's a lot of information, we have the Cliff Notes version, the condensed version, which is this book that you're seeing here. Now, you'll see me make some comments a little bit later on what do I recommend about this book. But typically, we already have about 5 to 6 copies available at our campus library, so you can check those out. So typically, because there's limited amounts of these, they're limited to about 2 hours at a time. Okay, so you're more than welcome to go check these out as soon as possible. Just keep in mind, there's a time limit. I also encourage you to work together. There's nothing wrong with sharing these, so you can all go together and start getting the information you need by there. Now, keep in mind, this is the only source you should be using. I'm going to say this a few times. Do not use any information from the internet. Do not use Wikipedia. Do not use Medline, et cetera, et cetera. None of those will give you the correct information, because everything that our particular test or project works on is straight from this book. There are no exceptions to this. It is only and only this book itself. Right? So if you decide to try and look up something about E. coli, let's just say you want to figure out if it's lactose positive or lactose negative, and you go online, first of all, you're going to find out that you have like 30 different strains, and each of those strains will be a little bit different. Some of them will be positive, some of them will be negative. How do you know which one? Well, we only use the one that is present in this document. So the one that we have in the lab and the one that you will use only comes specifically from this particular resource. So this 9th edition only of Bergey's Manual, this one alone. Okay. So again, there's plenty of copies available for you. We use them together. However, I'm not going to discourage you, not that you need to though, is you can always buy your own copy. There's nothing wrong with that, although you really don't have to do so. Okay. There should be enough copies at the library, enough for each section. So that shouldn't be an issue, right? But if you feel inspired, if you have the extra cash flowing around, you're more than welcome to do so. I will not discourage you from doing so, okay? All right, so use this particular book to transfer all that information to that matrix that we were just talking about in the previous section, okay? So these little grids, this book, that's how you fill this bad boy out. That's the plan, okay? That's all we have over here. All right, so now just again to remind you, since it is a very condensed book, even the writing is kind of tiny, it's very easy to get lost even in line per line. So ensure, for example, that when you're looking at any type of organism, at any particular type of test, that you pay attention to the details. For example, sometimes we'll say, hey, you need to look at a DNA test. But more often than not, rather than being the abbreviated version, it actually will say deoxyribonucleic acid rather than saying DNA. So sometimes you need to do a little bit of kind of logical thinking behind figuring this out. Also, the same thing as some of the tests when we took them in our labs, they had the alternative names. They had the enzyme names or the exoenzyme names. And so for us, for example, the word starch in reality is amylose. So we're also looking for in certain fermentation tests or certain types of liquid or broth tests, we were looking to see if the phenol red turned from red to yellow, right? But that was the production of acid. So in order for us to confirm that it was the actual positive or negative result, okay, the idea was to see if it turned yellow. That meant it actually fermented that particular glucose, lactose, whatever, and the entire broth turned that particular color. So look for the right responses. Make sure that you're aware of the definitions, the terminology, and all that stuff. And when in doubt, again, you can always ask us just in case, okay? All right, so continuing on, let me give you a little bit of an example of what this looks like. So I just kind of took a little bit of some pages in there. So I kind of took some quick screenshots to make sure we're not violating copyright. And let me show you kind of what it looks like. Every particular group of organisms, each genera, so the genus portion, part one of the two terms, right, will have like an introductory paragraph. Some of it is a quarter of a page, some of it is a half a page, some of it's a full page, depending on how much information we know about it. So always look there for any particular tests. Now, when the tests are pretty standard, when we have lots of information from all the species of them, then you can use the tables. And so in those tables, then you'll see the properties or characteristics that you want to know about. The idea is, for example, this is where you'd see glucose fermentation or acid, or you'd see lactose fermentation or lactose in acid formation, or whether it tests for sulfur or for DNase or for catalase. All of those guys, they're all set in these tables if it's pretty standard. The other thing you also want to know is that sometimes when you can't find something and we know for a fact we have it available, look at the bottom. Usually those pages have a little bit of a tiny little subscript or a little annotation that'll also tell you, hey, don't forget that the name might have been changed or updated, or don't forget that an extra table is available with this information somewhere else. So always look at the footnotes in there too, right? Now, once you kind of gather, as you can see, even just from the presentation, there's lots of positives and negatives, pluses and minuses, which can be at times a little bit of a pain to identify. So be careful when you're looking at these and cross-check them multiple times. I encourage you to use something like a ruler or something to make sure you're on the correct line. Now, even though they're kind of color-coded, you can see the little lines that are grayed out versus light. That'll kind of help. Make sure you always confirm which test you're working with. Now, as you complete your matrix, you'll notice that it's going to start looking like this a little bit, right? It's going to start getting pretty complex, a little bit messy, especially if you're not organized in your writing, right? But you'll see that we have a list of the organisms, right? Typically, you want to try and alphabetize these to keep these organized. And then you're going to see what are their gram designation, what shapes they have, how do they test in particular. Notice that in this particular example, somebody was annotating how long did it take for a particular test or any type of little notes that are in there. Now, what you're going to notice also is that when you have these tests, when you take these results from Bergey's manual, you'll also find out that not only you'll see just pluses and minuses, but you'll see all sorts of weird letters and numbers too. And that's where you really want to pay attention. And I'm going to emphasize this many times. Pay attention to what you copy. Specifically, those pluses and minuses is really what you want. But more often than not, you're going to see a letter D in lowercase or capital. You're going to see some of those pluses and minuses in little brackets, for example, which do not mean the same thing. Sometimes you'll see an asterisk. Sometimes you might see even other letters. So how do you know what each of them means? One, I'll mention this in a moment, but also every footnote will tell you. But for us, here's the deal. Trust only the pluses and minuses that don't have any modifications to them. Meaning if they look perfectly like a plus, perfectly like a minus. No extras, no addeds, no symbols, no nothing, no brackets, none of that. If it has any small little modification, if it's a letter, if it has an asterisk or underline or something like that, these are considered for us what we call a variable. That's going to be a word that you definitely want to know. Variables require some extra amounts of changes during the flowcharting process. So pay attention to it very, very carefully. Okay. So go for the pluses and minuses, fill those out correctly. And then anything else that you have, annotate it, copy it correctly, and remind yourself, these are variable data. All right. I'll explain what that means. Now that you actually have your matrix filled out, keeping in mind that since we've done this before, we know that your matrix should fill up. Now, it probably won't fill up to 100% of all the squares, but we can guarantee you that at least 90% of them will. So again, we've done this before. So we know that your matrix should be virtually almost complete. Here and there, you'll find one or two tests that most people can't find, and that's okay. There's nothing wrong. And even more so, let's just say it is available, but you don't find it. There's ways around it, just that means more work on your side. So I encourage you when you're looking for this information to look for it thoroughly, multiple times, even take a break and go back and look again, just to make sure that all of this information is as complete as possible and as accurate as possible as can be. So from there, then we're going to create our flowchart. Now, once you obtain Bergey's manual, once you put everything and complete that matrix as best as possible, again, reminding you that, yeah, sometimes you might miss one or two squares. Trust me, you're not going to be missing 30 of them. You're not going to even be missing 10 of them. Okay. You might miss 2 or 3 here and there, but that's about it. So that matrix should be about 90% complete. So complete it. And then once you figure out what you have, then you're going to start building that official flowchart. Now, again, let me remind you a couple of things about the matrix itself. Just because you're missing something doesn't mean a reason for panic. Trust me, there's ways around it. I'll show you what that means. But also do not try and look it up. If you have something missing and you're just going, oh, I think I can figure it out, trust me, don't. Only use the book that we provided you. Do not go to any outside source, because that will usually result with giving you the incorrect answer and then basically screw up the entire flowchart process for you. So don't look up any other source. Only use that particular edition, that color, that book, that specific source. Now, the other thing that is going to happen is that once you're creating your matrix and filling it out, certain tests only apply to certain species or to certain genera. So some of those will not really apply to you. So keep that in mind. All right. Now, there are a list of what we call forbidden tests, and we give them that name just to kind of make sure it's clear to you. It's not that you can't do these, but they usually have some sort of restriction. What does that mean? Is that sometimes these tests are either too complex, too dangerous or too risky, or let's just face it, too expensive. And so because we don't want to be wasteful, that means typically these are reserved only for the end of the actual flowchart or not at all. So that means usually you have to have special permission to be able to use these tests. Now, sometimes you will need them, sometimes you won't. I want to say about a quarter of the cases end up needing these, the other 75% doesn't, meaning that there's always a way around it most of the time. So when in doubt, if you reach these, take in mind that about 3 out of 4 chances, you don't really need to use it and you just need to find an alternative, okay? But in the event that these cases present themselves, you need to ask for permission first. So let me give you some of the more common examples. the urease test, the motility test, and the DNase test, simply because of how long they take or because of the nature of the medium that you're using, we don't approve those unless you do not have an option. And like I said before, typically you do. So more often than not, people are not reading or paying attention to their matrix itself, or they didn't cover the material correctly from Bergey's manual, and they're just kind of going straight to that. You will get those points wrong. So keep that in mind. Always double check your materials first. So it's not that you can't, it's more behind you really need to make sure you prove to us that you need these and there's no other option available to you at all. So, and these are usually towards the end of your matrix. Just keep that in mind. All right. Now, as you use Bergey's manual, the other piece is that, again, it's massive, right? Even for one book condensed edition, has a lot. So as you start looking for things, always go to the table of contents. It's easier to find things there or at the end of the actual book itself to look for the particular genus that you're interested in. Make sure you have all the information that you need from that bug list. Again, 95% of it will be filled up, right? And make sure that you have everything that you have, including the state of the wall of your particular organism, so the gram state itself. Make sure you're looking at all the paragraphs, make sure you're looking at all the tables and any of the footnotes. All of that material needs to be included in there. Now, in case I wasn't emphatic enough, again, make sure you're reading that document correctly. It's tiny, it's really dense, and you can easily get lost into all this kind of gray, black, and white colors of the letters. So always double check, triple check, and quadruple check the material that you're doing. Have somebody else check it for you too. Our eyes get tired staring at tiny little letters. So in order for you not to lose points and get put at the back of the line, have somebody else help you. It's okay. There's nothing wrong with that. Work together, help each other out. Absolutely, when you're looking up this information. Not when you're testing, but when you're obtaining stuff from Bergey's manual, that's perfectly fine. Ask mom, ask dad, ask cousin, ask brother to say, hey, what does that little plus sign look like? Is it a plus, or am I kind of blind a little bit from reading this thing too long? So always double check that information. Again, always check for spelling. What you may think is a malonate test versus a mannitol test, big difference in the tests, even though they sound and look almost alike, right? The same thing behind the difference between a sugar fermentation versus an oxidation. Even though the results look nearly identical, they have different purposes. So be sure to rely on all your knowledge, be sure to rely on your lab manual, on the supplement, and all the information you've been provided. Every single compendium we give you has all what those results need to look like or should look like. The colors, bubbles, any type of selectivity or differentiation, all of that is there. Okay, so we always give you that information. Now, just in case you thought I was joking, everybody has questions. And more often than not, we already know these. So I will give you the heads up now. We do have a quick set of FAQs. And when I say quick, let me emphasize that I meant very, very long. Because if you weren't listening to all the silly things that I just said, more often than not, you're going to go, can I do this? And to prevent any frustration on either side, we're going to tell you no. Simply because we know all this information is already present in the supplement, in the videos, in the handouts. So that means people are just kind of being a little lazy and they don't want to look stuff up. Here I'm going to tell you, go read it, right? So common questions that definitely do come up and sometimes are a little bit more difficult to answer are listed here. One of the more common things is, for example, at the end of all your tests, sometimes you'll reach a test and if it's difficult to perform or you don't have a confirmatory test, more often than not, you can. Typically what happens is you didn't copy the information from Bergey's manual correctly. And so what was supposed to be one positive, one negative ended up as two negatives or something like that, and you couldn't tell the difference. So always go back to your matrix, always go back to Bergey's manual to make sure you have the right information, right? Another common example is, for example, the testing time. Most tests have a limit between 24 hours up to 96 hours. And so your job is to determine the best time, and that's really best on you. You get to decide when you want to read these tests, keeping in mind that sometimes those tests can be best read early and sometimes best left read late. So you have to make those decisions based on what you remember, based on what you studied. So sometimes we even will tell you, hey, come and check it twice. Nothing wrong with that. It's not worth getting a false positive or a false negative just because you kind of jumped the gun a little bit, all right? The other one is, oh, I can't find that test. Typically, yes, you can. Like I said, we know we've done these organisms, so we know that that matrix should be almost 100% complete. And so don't use any other sources, as I keep on telling you, even though not all tests may be present in Bergey's manual. Again, though most of them are, it's up to you to either find them, confirm them, double check them, and triple check them. But also, if you can't, then you're going to treat those results as what we call variables. I'll show you that in a moment too. Now, another common question is, can I use the same test again? The answer is no. If you already tested something at the beginning, why would you test it again for the same purpose? It's wasteful and it accomplishes nothing. You learn nothing from that. So the use of a particular test only can take place if they're on different paths on your flowchart. If it's on the same path itself, as I'll show you in a moment too, it accomplishes nothing. So that's just being wasteful, okay? As we start grading your flowcharts, you're gonna realize that you're probably gonna use a lot of scratch paper. And this must be done on actual paper, hence why we gave you the matrix itself. So I know that people may wanna do this digitally, that's fine. If you wanna use it as scratch information, perfectly fine. But when you submit this, this must be submitted on the actual document we provide you, which is the matrix itself, okay? Now, as far as doing those tests, since we're gonna open up the labs for everybody at all points in time that we're available, students are welcome to come in at any point in time that any lab is available for us, meaning that Monday through Thursday, morning, afternoon, and PM, basically, everything is available as long as you have the time and you coordinate with your particular instructor. So we'll tell you how that works a little bit later. But the idea is all of those days are typically available so you can come and check your tests, so you can set them up, so you can run subculturing and so on and so forth. Just keep in mind, the ones we can't really change are any official holidays from the school, or for whatever reason, if there's some event going on or something like that, we really can't deal with those, right? So those are not available to you. All right, so let's get back to forming those flowcharts. Well, again, typically, once you're done with your first hour or so of doing your gram stain, your reactive oxygen species tests, you get your matrix, you get your basically your ducks in a row, and you request your matrix, then we give you your bug list with it. At that point in time, the remainder of that lab time is on you. Typically, we send you to the library so you can pick up Bergey's manual. Sometimes we have copies available with us, not always. And let's face it, having 30 students or so sharing one book, not very feasible. So most of the time, like I said, we send you to the library so you can check those books. And then you're going to start constructing your particular matrix and then constructing your flowchart, okay? So remember that at that point in time, once you're finished with your flowchart, once it is actually approved, then you can actually start with phase 2. However, the point behind your flowchart, again, is so you can identify all the possible organisms on your list. In other words, flowcharts are designed so you can isolate individual organisms, meaning that at the end of any particular pathway, there should only be one microbe, one microorganism at the end, showing us that you've isolated and identified that, right? So that means that flowcharts typically are played from top to bottom. That means that usually this is crafted in some sort of landscape format as well, which is one of the requirements for this particular test and project, all right? So the matrix paper that we're giving you is already designed that way. It is in already landscape format. You're supposed to complete this top to bottom. So I'll show you more or less what we want from here. Now, we're going to provide you with that bug list, which can be any number of the organisms we played with and some additional ones in the lab, right? And your job is to construct, as we did in Unknown 1, this dichotomous key, this game of 20 questions that we played at the beginning. And the idea is to come up with only yes or no, or plus or minus, or dichotomous answers, dual answers, right? And at that point in time, you will continue to construct your flowchart over and over until you isolate every single one of the organisms that is in your matrix, meaning your bug list. From there, you can then now draw out your flowchart, put it on the back of the matrix itself, keeping in mind that you probably want to do this in pencil, right? Because you're going to make some changes eventually. And then provide it to us so we can grade it. Again, first come, first served basis. So don't forget that part, okay? Now, just in case, again, we want to address every single possible frequently asked question, but also more than anything else is you want to probably maximize your points, right? So guess what? Let me give you a very perfect, thorough list of all the ways people usually normally lose points from. So here it is. It's dense, but this guy, honestly, print it out, have it written, use it as a checklist, okay? The best way to go about this is simple. Run through the list. So every single time you're about to submit your flowchart, go through the list itself. Have somebody else go through the list too. Again, double, triple, quadruple check. You'll hear me say this a couple of times. So things that typically cause us to just return the flowchart to you and say, nope, try again. You lost some points. Remember that we're trying to minimize the amount of time we spend on grading on these, simply because, again, there's way too many and we want to give everybody a chance. So each time you forget something, that means we have to spend more time looking for it. And again, it's not fair that we spend more time on yours versus somebody else's. So for that, here's the list. Common ways for us to say, nope, try again. You forgot to put your unknown number. Some of the silliest things that happen. All right. Since I don't know what your unknown number is, I don't know how to go about your flowchart either. So without that information, I can't help you. You forgot to include the list of possibilities. In order for me to make sure your flowchart is good, I need to know each and every single one of those organisms on your bug list. If you don't provide me that bug list, I don't know even what to test. And even though I would like to say, hey, I have these memorized, sadly, 100 of them, I can't break those down in individual bug lists. There's just no way. People forget to include their gram-stated reactive oxygen species tests. You forget to include them. We're going to tell you, here's some points lost. All right. Other silly things that most people forget is alphabetizing things, making sure that you use the genus as the way you alphabetize it, making sure that at least once you should be spelling this out fully, just like we did in topic 1. The idea is you spell it out fully the first time, and then after that, you can abbreviate it. Make sure that it happens before all the tests. Again, you can abbreviate it afterward. Making sure that the spelling is accurate, right? This is part of that testing of your skills, right? And make sure that you don't forget to include that sometimes these have subspecies. So like Salmonella species and a couple of other, those over there we may provide you, have subspecies names, okay? We're also going to pay attention to the fact that you're italicizing or underlining. And since we don't really trust the italics most of the time that we're writing, underlining is going to be the way that we go. So you'll notice that again, if you don't underline your organisms, you're going to lose some points each time you submit it. Not just once, each time we have to remind you, there go some points. Now the format is very simple. It's a quick checklist. All the positive tests in a dichotomous structure, positive tests always go on the left, negative tests always go on the right. Not of the entire flowchart, just per division. So each time you split something, positives on the left, negatives on the right. It is done from a top to bottom perspective. So you shouldn't be drawing around all these crazy lines going upward, left, down, in all crazy directions, only from top to bottom. You need to make sure that you provide us with your timeline of completion. In other words, here you need to be able to tell us whether or not the test is going to take 24 hours, 48 hours, 72 hours, or whatever. And you should be able to give us also your dates. Today, I don't know, let's say January 5th, I will start this and it should be complete on January 7th. So you should be able to provide us dates and the times of your tests. So make sure you have timelines. The reason behind this is simple. We are giving you a few weeks to complete this, and technically you could complete it if it takes you 3 months too. But then again, the course will be done, right? So you need to make sure that your timeline fits within the course too. Remind you again, the most common mistake I will tell you, aside from forgetting some little things here and there, are those variables that I talked about a little bit earlier. Meaning, what happens here specifically, you need to include those brackets, those letters D's, those weird little letters or symbols, they usually go on both sides of your dichotomy, meaning they should go on both the left and the right of your separation, since you don't know what the result is. Hence why they're called variable. As always, this is part of your note skill and handwriting abilities. So this is going to be done in a handwritten pencil format. So digital copies will not be accepted. Keep in mind also that this is done in that landscape format, hence why the matrix is that way. Remind you again that spelling is a big deal. So this is another common way to make sure you lose points, right? So just quickly check Bergey's manual. And then ensuring that anytime you have these variables, you're specifically highlighting them, letting us know that it was present in both pathways, okay? And those can be done by hiding them using colors or special underlining or something of that sort. Now, reminding you also that those tests that I mentioned earlier that were those so-called forbidden tests, all right? These specific tests, again, are restricted and can only be used at the end of an entire pathway if approved. So if you haven't consulted with your particular instructor, technician, etc., you cannot use these. So the second you say, hey, I'm going to use the urease test as my first test, you got your flow chart wrong. And we're going to send it back to you without even reading the rest. Just saying, go back to the drawing board, figure this out again, okay? So the most common ones, like I said, motility, urease, and DNase tests are the most common ones that happen. Those can only take place at the end, as I already explained before, okay? So when you're crafting your flow chart, if any of these things are not met, either you're going to lose points immediately, or we're going to send this back to you, and again, you go back to the list at the end of the list. Again, I need to move on to somebody else that follow my directions. So pay attention to how you're crafting these. Rely on this list. As a matter of fact, I have a second list for you that I'll show you a little bit later. Okay. Now, there are some tests that have some limitations too. Since, for example, certain tests only take 24 hours or 48 hours, you can't really start a fermentation test like on a Thursday, because obviously we're not open on a Saturday or a Sunday, right? So that needs to be planned as well, right? The other thing is that we want to make sure that we're trying to reduce contact and even contamination of your samples, because even somebody sneezing in there obviously can throw off your results. So your job is to show up to the lab, perform your particular tests, and that's it. Get in, get out. That's the plan, right? And keeping in mind, again, we're trying to train you to rely on yourself. So unless you have just kind of a simple question of, hey, what time is it tomorrow or something like that, we'll answer. But if you say, what's the result behind this? Or does this look green to you? Those will not be answered. So again, you need to rely on your knowledge, your supplement, your lab manual, etc. Okay, that's the plan. So let me give you some quick ideas. Earlier is better. The sooner you submit this documentation to me, the faster we can grade it, the faster we can help you out. Now, as we may be doing PDF files of the request materials or some of the reports, make sure you send them as soon as possible. Make sure you also, specifically for the matrix, that it's landscape. Make sure that your pictures are the best resolution ever, all right? And make sure that, again, you're handwriting these things simply because you're going to be going through corrections. And so even though digitally that might be easier, I need to be able to see what you got wrong the previous time. And so that means I need to ensure that that original copy is not modified, right? So I need to see the before and after to see that you actually learn what we told you to actually go fix, okay? Also, another common recommendation is, as you're going to be wanting to plan your time, make sure you're aware of your timings of your tests. And even though you might want to select the coolest test ever, which I do encourage, sometimes, again, Friday is not a good day to start off a fermentation test, but not a bad day to select a sulfur test, for example, which will last you 4 days. So plan accordingly. So prior to actually setting everything down, plan out your week, plan out your month, okay? Now, if your particular lab requires a digital submission of some sort, then there are certain stipulations. Now, this does not apply to everybody, so this may not be specific to certain sections, to certain labs, and to even certain courses like 102 versus 150, right? Now, if digital submissions are provided, that means this can be done for grading purposes alone. And that means we still require hard copies. But again, reminding you that going back and forth through digital submissions means tons and tons of emails. And if you look at just 2 or 3 corrections per student, and you're looking at 200 to 300 students at that point in time, we're talking about several hundred to several thousand emails done per session, per day. So this can get a little unruly. So that means that, again, you may need to be a little bit more patient as opposed to doing this in person. When you're submitting things digitally, remind you that always follow the directions of the actual paper, which means landscape for the matrix, landscape for the flowchart, or whatever position have the reports themselves, right? And so one of the more common mistakes that happens, and it is probably frustrating for your graders specifically, is the file itself. More often than not, you take a picture, but when you attach it through something like a phone, it's all quirky, meaning that it's coming, not straight, not upward, it's rotated, it's backwards, it has a live picture as opposed to a still picture, animations, boomerangs, etc., that kind of thing. So we can't read those. So those immediately are just kind of said, reply, no, try again. So need to make sure that when you're submitting a document, when you're submitting either a PDF file, which is the most common file we'll be using, be sure that it's in the right position. Make sure that it's attached correctly, meaning that even though you might have uploaded an image or a PDF file, it might not be rotated. And since we're grading these, the problem is the longer it takes for me to download a file, to rotate it, to open it, to see who it's coming from, because now I have to open a new screen, all of this takes time. All of this detracts from the grading process. So that means you're basically wasting time. So if it breaks those rules, we're just not going to answer. We're going to put you at the end of the list. It's not fair for everybody else that did pay attention and is following directions. Okay. So as soon as we get them in the first come, first serve basis, we'll start grading those guys as long as the time allots, right? If we're not in lecture or something like that, right? And then each time you'll lose something, it's going to be 2 points minimum, up to 10 points, depending on something critical. So each time we're sending it back to you, not only you're going to be placed at the back of the list, even through emails, but also you're losing points that you're not going to be able to recover even after you correct them. Point losses are final, okay? And so let's just say we tell you correct the spelling of this guy and you don't correct it, you're still going to lose that point again if you didn't fix it in the original file. This is why we ask you for both files, and this is why you go and use pencils for these things. So on the day of you submitting your flowchart, those days literally are just for flowcharts. We don't do anything else. Any other emails, any other business material are kind of put off at the end, and we only pay attention to grading. Since it is such a Herculean effort here, we need to make sure that all these are out of the way so that people can start. If we don't finish them, we keep on delaying everybody by a day, by 2 days, and their flowcharts no longer work. So flowcharting days are just for that, for grading flowcharts, right? So keep it in mind. We're going to be focusing on that. If you have any other questions relating to exams or something like that, we're going to put it on the back burner. So just remember that. All right. Now, in the event that you get a regrade, so we say, nope, this is not correct. You forgot your name. You forgot your bug list. You forgot to spell this correctly. You put this upside down. You put this on the wrong side, something like that. You're going to have to get a regrade. And so this is why you do this in pencil in the first place. This is why we don't usually do digitals, because we need to have the original copies. Okay. Keeping in mind that even though you're going to fix it, because otherwise if you don't fix it, the whole thing doesn't work, you still won't get those points back. You still have to be responsible for the points lost, but you still have to fix it. Okay. Now, since you're not going to get another matrix, since we can't provide you another, 14 by 18 page or matrix behind it, like the one we typically provide you, then that means you have to erase. You have to be careful. So the longer you do this, the more damage to that paper also occurs. Hence why you want to have scratch paper when you're doing this stuff first, right? You're also going to want to either submit through either an email if it's digital or in hard copy, the corrected one to compare. In other words, I don't know what you did to fix it simply because I have 200 other flowcharts. So that means I may have to ask you, hey, you told me to fix these 3 things. Here are the ones that I fixed in the new one. So sometimes you may need to tell me or even write it down saying, these are the 3 things that Chris told me to fix, right? So if it's digital, you want to include both files, not just the corrected one. If you submit me the corrected one, I don't know what you fixed. So that means I'm going to have to email you back saying, try again. You didn't give me the information I needed. And guess you're going back to the end of the pile once more. So be thorough with all these interactions. Now, as you're going to start submitting regrades, that means you're going to have to submit new flowcharts. Make sure you label these correctly. Always label your flowcharts with their state. Is this the original? Is this the first regrade? When you part, the second round, the regrade number 2, which would be the 3rd round, and so on and so forth. Always include your dates. That means the date from submission as well as the regrade behind them. This will allow us to tell which copy are you on, which step are you on, and how you're advancing and fixing these things. So in the files, for example, if you're doing digitally, remind us that, hey, this is Flowchart 1.0, this is Flowchart 1.1, 1.2, or whatever. Let us know that it's the original versus the regrade or something like that. Otherwise, it makes it very confusing for us to try and look for these, okay? Now, once all of this is done and you get an approval, like I said, literally the flowchart will say approved. If there is no signature that says this is approved with a grade, you cannot start, okay? Now, I do encourage you to be nice to everybody else. So every now and then, if we forget to add the word approved, then we told you, just let us know so we can write it down. Sometimes it does happen. All right, so now, the rest of the supplement has examples for you. So just in case you're like, hey, I don't know what's going on over here, we do give you some information. One of the most common ones is, what does it look like? Well, not only do I give you literally everything that I've said in the last 10 or 15 slides in a pretty little cheeseball picture, it is literally that way of saying, look, here's the full name spelled out. Here it is alphabetical. Notice that positives versus negatives, positives on the left, negatives on the right. I even kind of color coded them just to say purple versus red, but make sure you include all the tests. You can abbreviate the second time you use them. Notice that I'm including times. For example, the gram stain took 10 minutes. Remember that you need to include that, right? Make sure you include things like your unknown number, the bug list, your full name, your section, all that good stuff. Notice that again, it's only top to bottom. I'm not getting arrows going to the left or to the right or something weird, right? Notice that I'm labeling all the tests. Notice that I'm stipulating the times and the time frames. Notice that each time that I isolate one, I actually highlight it saying I'm done. There's no more tests I need to do on this guy. So it's there, right? Again, reminding you positives on the left, negatives on the right on each pathway. So keeping in mind the positive and negative is here, but also on this side, positive and negative, left versus right. So pathways may change, but the positive and negative on that particular test are always left versus right. The other thing is sometimes the tests can be repeated. So let's just say you're doing like a lysine test. If you start here, lysine, well, it serves you no purpose to do lysine down here since you already did the test you needed to do. But if, for example, you do, I don't know, here a malonate test, well, it hasn't been done to any of these. So you can do that here too. So it can be on the same pathway, but it can be on divergent pathways as well. So that's kind of overall everything I've been saying with some little minor details. But I did promise you, right, that all of these things can be summarized in a little checklist. Guess what? You have a checklist. Print this bad boy out, have it with you, and at all times, make sure you're kind of running through it before you submit it, or you risk heavily loss of points. But then you can go, well, that was just a silly example, and I'm going to answer very simply, nope. Here it is again. Students that have gotten at least 45 points or more on these particular flowcharts have been highlighted with their permission, by the way. So usually if I saw something that worked, even though it might not be pretty, but they did it well, that's all that counted. So you'll see, again, always top to bottom. Notice the positives and negatives. Notice that they highlight things. Notice that they give dates, all sorts of examples, right? I don't usually put their names or anything like that just to prevent, privacy issues, but they're there, right? So let me show you a slightly different version. Still top to bottom. This person kind of tilted it a little bit towards the right to make sure things fit. But again, top to bottom, highlights, Everything is organized, everything's spelled out correctly. They even provided me with a cool little key to say, hey, look, this is what this looks like. And so there's tons of them. So I've provided you many different examples on how this works, right? So any different way, you can adopt them. Even some people get cute enough to even give me kind of colored results of what they should look like. I thought that was kind of neat. You don't have to do that. I'm just saying that I found that kind of interesting, right? So these people, everybody underlines, alphabetizes, positives on the left, negatives on the right for each particular test, right? They're showing their isolations by highlighting them. They provide me with time frames, right? Top to bottom, you get the point, right? So tons of these examples are available over here. So please, please, please use these as your own reference. And it's not like 2 or 3. There's tons of these guys here, right? So you shouldn't have a reason why this shouldn't be working, right? So one of the things we're going to do in a moment is kind of do a practice version. And this typically happens per section, so I will not record this. So you should be doing this live with your instructor on how to craft a flow chart using a couple of examples we provide you. For example, there's 2 or 3 of these present in the supplement, and we kind of go basically from easiest to more complex versions of these with more rules and with more challenges behind them. So we'll perform that first as a way to kind of train you. And then we'll discuss, again, the checklist and everything else behind a particular one, all right? So that's the plan. So we're gonna stop with this presentation here.